Assalamualaikum. Hi, I'm Muhamad Nasiruddin Aiman bin Azaha. I am a student of Bachelor Hans of Science in Marine Technology, and I will be presenting my final year project entitled Comparative Biosorption Capacities between Sonneratia Alba and Rhizophora Apiculata for the removal of ammonia and nitrate from contaminated water. This final year project is supervised by Mr. Shari Aizat bin Kamaruddin. For this presentation, I will be explaining the background of study, problem statement, objectives, significance of study, literature review, methodology, results and discussion, and finally, the conclusion for this study. For the background of this study, it was found out that excessive ammonia and nitrate are contributed by anthropogenic activities, or in other words, human activities. Nitrate can cause methemoglobinemia and mental retardation in humans, specifically children, and eutrophication, toxic algal bloom, and hypoxia in environment. The presence of ammonia is proven to be toxic to marine organisms. So scientists have come up with studies to remove ammonia and nitrate from water by using activated carbon. The studies are directed towards the use of leftover plant biomass, which is more cost efficient. Among the problems addressed by this study are the use of coals and woods in production of activated carbon poses a major drawbacks in which coals are non-renewable resources and woods are overexploited for this purpose. And little to no studies have been made towards utilizing waste from mangrove plants in the production of activated carbon. Also, there is a lack of information on the effects of dosage of activated carbon made from Sonneratia alba and Rhizophora apiculata in removal of ammonia and nitrate from water. The importance of this study is that it would be beneficial to produce cost-effective materials to be used in removal of ammonia and nitrate from water, especially to organization which concerns water quality. And also, it is a significant endeavor to provide data and information regarding the potential of Sonneratia alba and Rhizophora apiculata for the improvement of water quality and also as materials to be used in the production of activated carbon. The objectives of this study are to compute the removal efficiencies of Sonneratia alba and Rhizophora apiculata for the removal of ammonia and nitrate from water. Also, it is to compare which species is better to be used in the removal of ammonia and nitrate, and also to investigate the effects of dosage of absorbents on the biosorption capacities. Next, we will move on to the literature review. From the journal Allometric Models for Above and Below Ground Biomass of Sonneratia Species, written by Kusmana et al. In the year 2018, I found out that the plants from Sonneratia genus acts as carbon storage, and from the journal Water Quality Criteria and Ecological Risk Assessment for Ammonia in the Shying River Basin, China, written by Ding et al. In the year 2020-21, I found out that non-ionic ammonia can easily diffuse through cell membranes. So, for the journal Biosorption of dye from textile wastewater effluent onto alkali treated dried sunflower seed hull and design of a patch adsorber, written by Augentimin in the year 2015, I found out that as the dosage of biosorbent increases, the percentage of dye adsorbed increases as well. From these journals, it was found out that activated carbon is a steady carbonaceous porous material which has a gradable microporous structure, wide surface area, great pore volume, and surface with adjustable chemical properties. And also, it is used in the wastewater treatment due to its porosity, favorable surface area, high adsorption capacity, great mechanical strength, abundance of functional groups, and thermally stable properties. Now I will be explaining the methodology of this study. So, firstly, the fruits of Sonneratia alba and Rhizophora apiculata were collected from Sungai Merbuk, Sungai Petani Kedah, and then for the cleaning and separation process, the peels and seeds of both fruits are separated. And then the thermal treatment, in which the samples were carbonized at 700 degrees Celsius for 20 minutes, and then it was activated using potassium hydroxide. And then for the removal of ammonia and nitrate, it was done using different dosage of adsorbents, which were 1 gram, 2 grams, and 3 grams. For the results of this study, we'll start off with Sonneratia alba. Before anything else, I would like to note that all the computations of data in this study were calculated using equation 1, equation 2, equation 3, and equation 4. For the test of ammonia removal for Sonneratia alba seeds, for the dosage of 1 gram, the removal percentage is 7.4074. For dosage of 2 grams of adsorbents, the removal percentage is 33.3333%. And for dosage of 3 grams, the removal percentage recorded 74.0741%. Then, for the pills of Sonneratia alba for the removal of ammonia, the first dosage, which was 1 gram, recorded removal percentage of 33.33%. For dosage of 2 grams of adsorbent, the removal percentage was 51.8519%. And for dosage of 3 grams, it resulted in removal percentage of 81.4815%. To compare between the seeds and peels of Sonneratia alba, it can be seen from the graph that the peels of Sonneratia alba is superior to that of its seeds in terms of removing ammonia from water. Now we have a look at the removal of nitrate from water by Sonneratia alba seeds. So for the dosage of 1 gram, it resulted in removal percentage of 8%. For dosage of 2 grams, the removal percentage was 16%. And for the dosage of 3 grams of adsorbents, it resulted in removal percentage of 28%. For Sonneratia alba peels, the dosage of 1 gram resulted in removal percentage of 20%. For dosage of 2 grams, it resulted in removal percentage of 36%. And for dosage of 3 grams, it resulted in removal percentage of 60%. To compare between the seeds and peels of Sonneratia alba for the removal of nitrate, it can be seen from the graph that the peels have higher adsorption capacities compared to its seeds. And this is in agreement with a study by Lakshmana Naik et al. In the year 2020-2022, in which they found out that addition of orange peels to rice husk improved its adsorption due to presence of carboxyl and hydroxyl group. This relatively suggests that peels generally have high adsorption capacities. Now I will show the results from Rhizophora apiculata. For the removal of ammonia by Rhizophora apiculata seeds, the dosage of 1 gram resulted in removal percentage of 52%. Dosage of 2 grams resulted in removal percentage of 94%. And for the 3 grams of adsorbents, it resulted in removal percentage of 100%. For peels of Rhizophora apiculata, 1 gram of dosage resulted in removal percentage of 35%. 2 grams of dosage resulted in removal percentage of 70%. And 3 grams resulted in removal percentage of 94%. For the comparison between Rhizophora apiculata seeds and peels, it can be seen from the graph that the seeds of Rhizophora apiculata have higher removal efficiencies compared to its peels, and this result is utterly similar to that of in studies by Giri et al. In year 2022, in which they acquired results that the biosorption made from seeds of Artocarpus heterophyllus and Syzygium cumini recorded removal percentages of 93.8% and 93% respectively. For the removal of nitrate from water, Rhizophora apiculata seeds are recorded these results. So as can be seen there, the first dosage, which is 1 gram, resulted in removal percentage of 10%. For adsorbent dosage of 2 grams, it resulted in removal percentage of 35%. And for 3 grams of dosage, it resulted in removal percentage of 60%. For pills of Rhizophora apiculata, 1 gram of dosage resulted in removal percentage of 15%. Dosage of 2 grams resulted in removal percentage of 35%, and 3 grams of dosage resulted in 60% of removal percentage. For the comparison between Rhizophora apiculata seeds and pills for the removal of nitrate from water, it can be seen from the graph that both components resulted in similar data for their maximum removal percentages. And this suggests that the seeds and pills of the fruit can be used interchangeably for removal of nitrate, as the difference in their removal efficiencies is negligible. Now we'll have a look at the comparison between Sonneratia alba and Rhizophora apiculata for the removal of both ammonia and nitrate from water. For the removal of ammonia from water, it can be seen from the graph that the highest removal percentages resulted from seeds of Rhizophora apiculata, and the lowest removal percentages resulted from seeds of Sonneratia alba. And also from the graph, it can be seen that both seeds and peels of Rhizophora apiculata have the highest removal percentages in compared to peels and seeds of Sonneratia alba. Next, for the removal of nitrate, it can be seen from the graph that the peels of Sonneratia alba, the seeds of Rhizophora apiculata, and also the peels of Rhizophora apiculata all resulted in the same maximum removal percentages. And the lowest removal percentages resulted from the seeds of Sonneratia alba. Now we'll have a look at the effects of dosage on removal percentages. From the previous tables and graphs shown earlier, it can be seen that as the dosage of adsorbent increases, the removal percentages also increase. Song et al. Explained this by stating that the increase in amount of adsorbent increases the quantity of sites of adsorption, and thus more particles of the analytes can bind to the surface of the biosorption. And this claim is also supported by similar explanations by Huang et al. And Gupta et al. This actively suggests that as the dosage of activated carbon made from peels and seeds of Sonneratia alba and Rhizophora apiculata increases, the adsorption site for ammonia and nitrate increases as well. And as a result, the removal percentages increases as shown in the tabulated results and graphs. Now, to sum up this study, for Sonneratia alba, both removal of ammonia and nitrate, pills of Sonneratia alba have recorded higher efficiency in removing the analytes compared to its seeds. And the results from removal by Rhizophora apiculata concluded that the seeds has higher removal efficiency in comparison to its pills. And to compare between both species, the most suitable one to be used as biosorption is Rhizophora apiculata. And for the effects of dosage, all recorded results suggested that with the increase in dosage, the removal efficiency also increases. The findings from previous studies also support this claim. Hence, removal efficiency can be optimized by increasing the dosage. That is all for this presentation. Thank you.